Hello everyone, this is Naushad Jaman.
And this is Rashidul Haq. Welcome to our video presentation on pattern recognition. The symbols that were given to us are shown on the screen, and these are the two extra symbols we did. To follow a similar algorithm, first we separated the symbols which have a long straight line in them. For example, P, J, T, etc. The codes for these symbols contain similar starting. Let's start with Z. To find the equation of the longest line in Z, which is this, we first stored the slopes of the straight lines joining every 2 points. Then we sorted out for which points the slopes are very close. Here we get the straight line found by the sorted out slopes. Now we have to focus on the points out of this line. If we draw the perpendicular bisector of the line, the system is divided into 4 quadrants. For Z, 2 sets of outer coordinates would be in opposite quadrants, that means 1 and 3 or 2 and 4. Now by solving the equations of these two straight lines, if points of one side gives positive value, the points of the other side will give negative value. Using the phenomena, we sorted out the points into 2 sets and joined them with the nearest edge of the straight line.
And here's our code for Z. And if we observe the output, we get Z. Our code also works for a flip Z.
Almost similar logic as Z was used for the coding of T. Just in this case, the quadrant of the outer point sets would be adjacent.
This is our code for T and this is the output.
For F, all the outer coordinates would be on the same quadrant. First, the longest line was found using the same procedure. The most distinct outer point was found by determining the perpendicular distances. Then, the nearest edge of the line from that point was found and the equation for this straight line was determined. Points in this set would nearly satisfy the equation. Repeating one similar procedure, the rest of the points were joined.
This is our code for F and here is our output.
For 4, similar algorithm as F was used. First we found out the longest line. Then we sorted out the most distinct point and determined the equation of the straight line going through the point and the nearest edge. At last, we joined the rest of the points from the most distinct point to the nearest point on the longest line.
Here is our code for 4 and here is our output.
The procedure to distinguish between F and 4 is that these two sets of outer points in F are almost parallel and for 4 it is not. The algorithm of L is just as F. The only difference is that in this case we won't get a second set of outer points.
The output for the code of L is this. For P, after finding the longest line using any other 3 points, we solved an equation of circle using this formula. If the symbol is P, all the other outer points would nearly satisfy the circle's equation. This is the code for P and this is our output. The algorithm of small j is just as the algorithm for the straight line. The only new installation is that higher tolerance for the line was used to join the crook bottom.
Here goes the code for J and here is the output. For C, 2 edges were sorted out and was joined by a straight line. Then the most distinct point from the line was found. Now using these 3 points, an equation of circle was solved just like we did in the algorithm of P. All the points nearly satisfies the equation within tolerance. Here goes the code for C and this is the output. When we examined our codes with defined coordinate system, we found out some flaws. For example, in our codes for C, the 2 points of the edges must have the maximum distance between them. If the symbol were very crooked, our code would not work. Again for P, if only the head of P is nearly circular, then our code would work. For elliptical head, it won't work.
Here we merge all the codes in a single main function. Here all the coordinates of symbol arranged together. If we give the coordinate for P, the output is this. And in command window, it shows that the symbol is recognized. Here we are doing similar work for the coordinate of Z.
Thanks for watching our presentation. If you have further query, please contact us.